In this video, we will talk about L'Hopital's rule, which will help you solve indeterminate forms of limits such as these. For contents like this, subscribe and comment the topic you want to study next. Let's start. For indeterminate forms such as infinity over infinity or 0 over 0, we use this rule. There are other forms of indeterminate as well, but for this video, we will focus on these two forms. For an expression fx over gx, when the limit x approaches 0. Plug in x for 0. Let's assume that fx becomes 0. Plug in x for 0 in g as well, and it becomes 0. Then this is 0 divided by 0, an indeterminate form. According to L'Hopital, you can solve this expression once you do the derivative on top and bottom and eventually plug in x for 0, you should get a valid answer. Let's see some examples. We have sine 13x over sine x and the limit x is approaching 0. Well, if you plug in x for 0, 13 times 0 is 0. So you have sine 0, and then in the denominator you have sine of x, which is 0, which becomes 0 over 0. It's an indeterminate form. So we'll apply the L'Hopital rule. In the next line, you will have the same limit, and I'll do the derivative. So d over dx of sine 13x and d over dx of sine x. Limit x as 0. The derivative of sine 13x is cos of 13x. And since we have 13x, we use chain rule and do the derivative of 13x, which is 13. The derivative of sine x is cos x. And now let's try plugging in x for 0. You have cos of 13 times 0, which is 0, times 13 over cos of x, which is 0. We know that cos 0 is 1, so you have 1 times 13 over 1, which is 13. Let's see the next one. We have x6 minus 1. When you plug in x as minus 1, x6 becomes 1, so 1 minus 1 is 0. When you plug in x for minus 1, x4 becomes 1 as well. 1 minus 1 becomes 0. It's an indeterminate form, so we use the rule. Limit x stays minus 1. Do the derivative of top, you get 6x5, and the derivative of bottom gives you 4x3. Now you have 6 times minus 1 to the 5, 4 times minus 1 to the power 3. 6 times minus 1, 4 times minus 1, 6 over 4 or 3 over 2. Let's see this one. Tan inverse 2x. X is 0, so tan inverse 0 is 0. 3 times 0 is 0, so it's 0 over 0, an indeterminate form. We use the rule. X goes to 0. The derivative of tan inverse x is 1 over 1 plus x squared. So 1 over 1 plus 2x whole square in this case. And because of chain rule, we do the derivative of 2x, which is 2. And the denominator 3x, the derivative would be just 3. Now we have limit x going to 0. 1 times 2 is 2. 1 plus 4x square. This is together. And then times 3. Now we can plug in x for 0. You get 1 plus 4 times 0, which is 0, times 3. Overall, it's 2 over 3. In this case, ln x, x going to infinity, so this would be infinity, and then this is infinity as well. This is infinity over infinity, and indeterminate form, so we use the rule. We have limit x going to infinity. Take the derivative of top, you get 3 times ln x whole square times the derivative of ln x, which is 1 over x. So x goes in the denominator, times the derivative of x2, which is 2x. Now we have limit x going to infinity. Using the rules of log, this 2 can come at the front, and you have 3 times 2 ln x over 2x square. 2 and 2 can be cancelled. ln x, and x is infinity, so the top is still infinity, the bottom is still infinity. In this case, we will apply the rule again. The limit stays infinity. The derivative of ln x is 1 over x, and the derivative of x square is 2x, and this 3 stays right there. Now you have limit x going to infinity, 3 over 2x square. We know the rule, limit x going to infinity, 1 over x is 0. We have x in the denominator, so this expression becomes 0. If you understand these examples, apply L'Hopital's rule in these problems and write your answers in the comment below.